All right, first question is, what do you think a scatter plot is? So it's, we're going to plot points. So it's plotting points. So plotting points to show yeah. Hold on one second. Ethan, what do you need? Yeah, that was supposed to be an A right there. It says plotting points to show a relationship between two sets of data. All right, so all we got to do on this first one right here, we just got to plot the points. That's all. Now, the only problem is, I think if you looked at that, whoever made this this note packet, can you see they messed up the scale on the y-axis? Here, let me zoom in on it a little bit. I'll keep the data in here, though.
Oh, yeah, wait, no, what? They skipped what's normal?
Again, quiet again, guys. What's wrong with the scale on the y-axis?
It only goes to 6.
Yeah, it only goes to 6. Look at the first point. It got to have 1, 24. So I think we're going to rewrite that, okay? So we're going to rewrite this like, well, 0 is still going to be there, but this is going to be 4, 8, 12, 16, 20, 24. Okay, so we're counting by 4s on the y-axis. Does that make sense? All right, now it'll fit, right? So let's graph it. So the first point, again, well, I should probably, the other thing you should do on these, you got to label the axes too. So it was time on the top, right, of that chart. So time will usually go on the x-axis, okay? So this is going to be time down here. And I believe it says it's in days. And then on the other axis, on the y-axis, it's the number of cookies. All right, now we'll plot them. So the first one is 1, 24. You guys see this, right? There's your first point right there. So 1, 24, so that's 1 right, 24 up. So that's here. Then you got 2, 16. So 2 right, 16 up. And then 3 right, 10 up. Well, for 10, you're going to have to get halfway in between 8 and 12, right? So that's 3 right, 10 up. And then 4 right, 7 up. So that's going to be a little bit less than 8. So like right, what would we be at? 6, 7, so like right here. And that's it. That's all we got to do on that part. Is just all I wanted you to do is graph the points. Do we connect them? No. No. No, it's in whole number days, okay? So it's not in half days or anything. All right, then the next part of this, you just have to look at the data and decide whether the correlation is positive, negative, or whether there's no correlation. So let's look at these at the bottom here. All right. If both quantities are increasing, then it's called a positive correlation. So on that first one there, you should see as the x values are increasing, the y values are also increasing. So we're going to write positive correlation. So this one is a positive, I don't want that color. Positive correlation. All right, and then the next case. In this case, the x values are increasing. What are the y values doing? Yeah. So that graph is going downhill left to right. So if you got one that's going downhill left to right, it's going to be a negative correlation. The first one was going uphill left to right. That's a positive correlation. So this is a negative. And I'll just abbreviate it. I'll put CORR for correlation. What about the third one?
Neither.
Yeah, there's no correlation, right? Just, there's no pattern in that data. So this is no correlation. And that's the first page of the notes, so that went pretty quick. All right, so flip the page over. So we only got one more section in the chapter. We'll do that tomorrow. And then we'll do some kind of practice on Thursday. We got the chapter 4 test on Friday.
Great.
I can't wait.
Okay, now these 1, 2, and 3, you got to decide whether the correlation is positive or negative, or whether there's no correlation. So this one says, the first one, it says the come on, I'm recording this.
Sorry, guys.
All right. So as the temperature increases, what happens in the number of beach visitors? Does that increase or decrease? Yeah, as the temperature increases, it says an increase in temperature, the number of people at the beach increases, right? So is that a positive, a negative, or no correlation?
Positive.
Yeah. So you write positive. So this one is a positive, I'll just write it right here, positive correlation. All right. The next one, what about a correlation? Is there any correlation between the temperature and the number of speeding tickets?
No.
Yeah. Yeah. Well,
Yes.
Maybe between the temperature and road rage tickets, but
You gotta get their ice home.
but I don't think there's probably a strong probably not hardly any correlation there. Okay, there's no correlation between temperature and speeding.
I mean, more people are gonna be on the road.
Maybe,
And then you know how fast they are.
but it wouldn't be a strong correlation. So we're going to write no correlation,
Yeah.
or you could write none. All right, the next one. The one quantity is the time. So the time's going to increase, right? You're running a race. The time is going to increase. What is your distance to the finish line going to do? That's going to decrease. So is that a positive or a negative or no?
negative.
Negative.
Yeah, that one's a negative. Yeah, so as the time increases, the distance to the finish line decreases. Now this next one, we just got to make up a scatter plot. But what do you think is going to happen as the age of the car increases here on the x-axis? What do you think is going to happen to the cost of the repairs, Ryan?
It's gonna go up.
I asked Ryan, yeah, he said up. Yeah. Now if it would have been the age of the car versus the amount of money that the car is worth, it would have been what? It would have decreased, right? Yeah. So if you would have done the age of the car increasing, and this axis over here would have been the value of the car, it would have actually gone down, right? But this one, the cost of the repairs as the car gets older goes up. So we're just going to make up a scatter plot here. All right, I'm not going to scale these axes and get real specific, but we'll just draw one. So you would get something like, I don't know. In the beginning, the cost of the repairs would almost be zero, right? Because it'd be brand new. I guess at zero time, you wouldn't have any repairs. And then eventually, the cost of the repairs is going to start to go up a little bit, right? And then maybe it'll jump up. So maybe something like that. And again, I'm not going to get real specific on this. We'll just leave it. But you might get a scatter plot that looks something like that. The cost of the repairs don't go up very much in the beginning because the car is brand new, but eventually they'll increase. All right. And then what you can do next in that next blank, it talks about trends, and they can be represented with a trend line. And below that, it says that a trend line is a line of best fit. It's a line that best fits the data. So like, for example, the one we just drew there, is that a positive or a negative correlation?
Positive.
It's positive. And then the trend line, you want to try to draw a line that comes as close as possible to hitting all of those points. In other words, you want the distance between the points and the line, the trend line, to be a minimum. So you want to draw a line in here, something like, I don't know, maybe something like that, maybe. So you want to come as close as you can to hitting as many of those points as possible. And you want to minimize the distance from any of the points to the line. So that's your trend line. And then you're going to make predictions based on your trend line, but I'm not going to do that on this one. I'll do it when I'm going to give you the packet now. So you have a 3-page worksheet again. It doesn't have a lot of problems on it. In fact, it's got a few more problems than yesterday, but it actually takes less time. But here, label this thing. Hold on, I'm not done. This is your trend line, right? So that thing right there, that's your trend line. Hey, I'm recording. All right. So a trend line, again, it's also called the line of best fit.